Okay, I am recording. Admit Perla. All right. I thought it said Matt was joining. I don't see him.
I'm here.
Oh, you are? Okay. I was like, where's Matt?
I'm just not showing video this time.
You're good. You're good. I missed your face, Matt. All right.
Oh, so, not special.
I know. We'll go ahead and start. Okay. Now, this is another thing. I'm going to say, Matt, how often are we going to use this next year or next semester?
Every day.
A lot, right? So dilution, percentage, powder volume, this is going to be super, super important next semester, but we really need to master it now. So when we talk about powder volume, I'm talking about a powder drug, right? So yeah, powder drug. Specifically, what or where will I find this powder? You can either say it or type it out in the chat. Where will I find this powder?
In the vial.
In the vial. So I'm going to draw my beautiful picture of a vial, right? Yeah, terrible. So usually drugs will be supplied in powder form. So this is for a lot of reasons. It's probably stability and expiration, whatever, doesn't matter. But injectable drugs will be in a vial, and they usually will be powder. I'll ask you again, can you inject a powder into someone's veins? No, right? It would not be good for multiple reasons. You cannot inject a powder into someone's veins. But we can do something that will make it to where we can. And what would that be?
Water in it.
Yeah, put water in it, right? What is that water called?
Diluent.
Diluent, right? So now I have put water or diluent, whatever it is, in a liquid. So let me draw that. I'll draw the states of things right here. So
Punky.
Do what?
No, not much.
You're
doing a Zoom thing here.
Can you mute yourself, Matt?
Oh, sorry.
Thank you.
Sorry, my bad. I thought I was muted.
You are not now.
Well, hang on.
I can mute you. There you go. Okay, so if we're talking about the states, like the condition, okay, so the diluent is obviously a liquid. Powder is obviously a solid. When we add those together, what do we form? What is the state of this entire mixture?
What else?
A solute.
So sort of, I mean, you're on the right track, but this is a solution or a liquid, right? If something is a solution, it is one uniform mixture of powder and diluent. Okay. How can I still hear Matt? Okay. So it is one uniform mixture. So can you separate that now? No, right? It's one mixture. So I'm going to draw that again real quick. I'm going to draw it a little bigger this time. Okay. All right. So I'm going to go ahead and highlight this right here. And I'm going to go ahead and highlight this right here. I'm going to go ahead and highlight this right here. How many blanks is that? That's 3, right? You already know where this is going, I hope. Okay, we'll go ahead and call this one 1, 2, and 3. Okay, so let me go ahead and I'll just color my solutions. Okay, So that's like this blue.
Yeah.
Okay. All right. So go ahead and tell me what number 1 is.
The powder.
Powder. Specifically, I want you to say powder volume, right? And I drew that over there to show you that it's taking up space. That volume is taking up space in the vial. Okay, what is number 2?
Diluent volume.
Exactly. Okay. And if you look, number 3 is surrounding the whole thing, right? It includes both powder and diluent. What is that?
Final.
It's total or final. Yeah, you're right. Okay. So, and I know I've covered this, but I wanted to go ahead and draw that graphic out, showing you that we have one thing called diluent, one thing plus powder, and that is making up our entire solution. So, just like I showed you with the needle and the syringe and the vial and all that stuff, after you added that, we formed a solution. So can you see both of those compounds in there? Can you see both of them? Well, no, you can only see one, right? It's a clear liquid. You can't see the difference because it's a solution. Okay, so let's go ahead and write out my formula again. So we have FB equals PB plus DV. So if I'm gonna mess up the colors. Let's go ahead and put this in pink. Okay, so my final volume is my pink one. My diluent is my orange one, different color, whatever. And then my blue one is powder. Okay, and I'll draw arrows. Final powder. And then diluent. Okay. So just remember, those are the only ingredients I'm putting in here. Powder, which is drug, diluent, which is just a liquid, and then the final volume is the entire mixture once it's mixed up. So let's look at an example. Okay. All right. Okay, so this one says calculate the concentration in milligrams per milliliter after reconstitution with 19 mils of sterile water of a 2.75 gram vial if the drug has a powder volume of 2.2. Okay, so I know there's a lot, but we're going to digest that down. Okay, so you already know it's a powder volume problem because you have powder volume in the question, right? I'm going to go ahead and highlight that for y'all. So powder volume, right? That's a good indicator that it's a powder volume problem. So on every powder volume problem, I want you to write the following. I want you to write FV DV PV. Okay. That right there is going to help you calculate that because I'm going to write it down eventually, but if you remember the equation, FV is equal to PV plus DV, right? So just 3. That's the only thing you need. Okay. I will go ahead and highlight in a different color my final volume. Do I have final volume in that problem? Do I have it anywhere? I don't think so. Okay, so moving on. Do I have dV? Do I have dV in that problem?
Yes.
I'll give you a hint. This is a good clue,
Else.
right?
Oh.
So I'm going to go ahead and make a note right here, and I'm going to go ahead and make it on a different page. When you see SWFI, or sterile water for injection, that is the diluent. Okay, every time you see sterile water, or maybe injectable water, or whatever it's called, every time you see the word water, that is a good indicator that that is your diluent. Okay, every time. So now I'm going to go back up here. I've already highlighted. I have my diluent volume, which is what? 19 mils. Next color, I'm going to do PV. Oh, whoops. PV. Looking through that problem, do I have PV in that problem? Yes, I have it right here. Okay. What is my powder volume? 2.2, right? So if I have an equation that is FV equals PV plus DV, and I'm solving for this, do I have enough variables, or do I have enough parts to solve that? Yes, right? I only have one variable. So go ahead and solve that with me. So we have 19 over here plus 2.2. So I just add those together and solve for my final. So that is what, 21.2? Did I do that right? Yeah. Okay. So 21.2, is that my final answer? No. So right here at the beginning of the question, you can kind of get caught up in these problems because there's a lot of steps to get to your answer. So finding the final volume was the first important step. Now we need to calculate the concentration of this drug. I'm going to write another thing on this page. When finding the concentration of a reconstituted always use final. Okay. That one's huge right there. Always use the final volume when you're solving for your concentration. Now we're going to go back to that problem, but I'm going to ask you, think to yourself, if I'm solving for the final concentration of a drug that started as a powder, doesn't it make sense to use the final volume, right? After I mix it with water, after I bring it into solution, that's what you're going to use. So if you have a problem in front of you and it says, what is the concentration? You need to pause right there and you need to say, I need to use the final concentration. Okay, let's go back to our problem. Final volume, what is that? 21.2, right? You've solved that already. How much drug do we have? 2.75, right? That's 2.75 grams. Okay. Now, if we look back at the question, what is the concentration in milligrams per milliliters? Can I use my 2.75 grams? No. I need to convert that into milligrams. So I'm going to do this. If you do a proportion you will do, and this is your proportion, and I'll explain this, 1 gram, 1,000 milliliters or milligrams. You will do 2.75 times 1,000 divided by 1, which is 2,750 milligrams. Now I'll pause right there because a lot of people get confused when I do that. How many of you got confused when I did that? Anyone? Okay, so if you get confused by that, you can think back to the simplest way you can do that conversion is to think that gram is a base unit. So if it's a base unit, that is where you start. If it is a milligram, you need to divide by 1,000. If it is a kilogram, you need to multiply by 1,000. So I'll write that out. Right here is gram. Right here is milligram. This is kilogram. This is 1 over 1,000. This is 1,000. And then this is 1. So if you want to take 2.75 grams, 2 milligrams, you'll just divide by 1,000. And that's how you get your answer. Okay. So back to our problem. I now know that we're working with 2,750 milligrams of drug. I now know that we have 21.2 mils of final product, 21.2 milliliters. So in our problem, or in our question, we need to find milligrams per milliliters. Do I have milligrams per milliliters right here? That's it, right? I have now solved the problem. I just need to, do the calculation. So, oh, I just locked it. Give me 1 second. So 2,750 divided by 21.2. What did y'all get? Oh my gosh. 129.72. Is that what y'all got? Yeah. Okay. That's my answer. So there was a lot of parts here. I know I talked for a long time, but the first thing you need to do, get your variables listed out. On powder volume questions, you can really get confused if you don't have your variables identified. So powder volume problems, always final, diluent, and powder. Next part of that is to find the final concentration, which is to use the amount of drug you have divided by the final concentration, right? I wrote right here, when you're looking for the concentration of a diluted product, always use the final volume. Okay. Did that sort of make sense? No, it's okay. As long as you just remember to work through that, once again, as we leave or as I leave this meeting, I'm going to open up the homeworks to where you can take unlimited attempts, and I'll take the highest. But when you work through it, I really want you to work on pencil and paper. I used to do everything on pencil and paper, but now that the class is so big, I have to do it in Blackboard. Use pencil and paper and write those variables out, just like I have right here. So, I have my variables on this side, I have my calculation on this side, and then I get my final answer. So when you do that, follow that. Does anyone want me to do something else? Different one, same one? Anyone?
Can we do one more?
Yeah. Let's see. What would concentration be? Okay, so here's one where we're going to find the powder volume. Okay. 13. All right, so I'm going to read that to you. So to prepare 3 grams of unison, the package you insert states to add 6.4 milliliters of diluent. The concentration obtained is 375 milligrams per mil. What is the powder volume of the unison? So that's a little bit easier to digest than the previous one because it's laid out with words. But once again, when you have identified that the problem is a powder volume, I want you to start with FV, PV, DV. And you can go ahead and write the formula below if you want. Okay. So once again, I'm going to start highlighting. Okay. All right. So FV. Do I have an FV in that problem?
Yeah.
Not really, right? Not really. So if you look, this is not my FV. That's the final concentration. Okay, we'll talk about that. Okay. PV. Do I have a PV in here? No, that's what I'm looking for. So I'm gonna go ahead and put a question mark there. DV. Do I have a DV?
Yeah.
It says it right there, right? Diluent volume. So I'm gonna go ahead and write that. 6.4 milliliters. All right, so let's go back to our final volume because we're gonna have to do a little bit of math. All right, so I'm gonna highlight in yellow my important things that I'm gonna need to do this. Number one, I'm gonna need to know how much drug I have. How much drug do I have in this problem?
3
3
grams.
grams. Perfect. Is there anything else in that problem that tells me anything about the drug? Right? 375 milligrams per mil. So milligrams per mil, if you remember that anytime you see this slash, you read that as per mil. If you see that, you know it's going to be milligrams over milliliters. So if it's 375 milligrams, how many milliliters is that?
1.
1, exactly. So what I'm going to do is, this is my concentration. So I'll tell you, I'll give you a hint. This is going to be my okay. That's my final concentration. This is my drug. Do I have anything that can go on either of these sides? Anyone? I have it highlighted in yellow, if that gives you a hint. Right here, 3 grams. So I need to put 3 grams somewhere. And if I know anything about proportions, I know milligrams is on top and milliliters is on the bottom. We already know there's a problem here. I have grams and not milligrams. So just knowing what you know, do you know how many milligrams are in a gram? Or what is my answer? 3 grams is how many milligrams?
3,000. 3,000.
Perfect, right? Because if I do my timeline again, you know, whatever, I have my grams, kilo, milli, 1 over 1,000, 1,000. So I'm starting in the middle and I'm going left. So I'm going to divide, I'm sorry, I'm going to multiply by 1,000 and it's going to turn into a bigger number. So 3,000. Let me get rid of that. Okay, 3,000 milligrams. Do I have everything to calculate that number now? Yes. 3,000 times 1 divided by 375.
Eight.
8 what?
milliliters.
Perfect. 8 milliliters. Okay. So if on my left side, I have final concentration, my right side, I have drug. What do you think the number that I just solved for was?
Final volume.
Yes, right. So now I have just solved for this. Okay, in that equation, I have 2 of my numbers identified. Does that mean I can solve for my other one? Yes. So I have 8 equals 6.4 plus unknown. So if you know anything about algebra or just arranging formulas, how do I solve for that? I do 8 minus 6.4. Did you get 1.6? Okay. Okay, so what I've just written, the final concentration is the amount of drug over the volume of the final product. So, whoa, I just messed up. So this could be grams over milliliters. This could be milligrams over milliliters. This could be mcg over liters. It doesn't matter. As long as you have the amount of a drug over the volume of a final product, that is going to be your final concentration. So if you are supplied with a final concentration and you see mg/ml, you know right there that is the amount of drug over a volume. So you know it's already reconstituted. You know it's already been diluted. Okay. When you see percent strength, what do you think?
Grams per 100.
Right, grams and 100 mils every single time. So right there, does that sound a lot like final concentration? Right, because it could be, you know, if you're solving for a percent strength, it means you have diluted it. You know, doing that percent strength, you're already doing a dilution, so they are related. So this could be. Okay. Dilution. Not changing the amount of drug, changing the diluent volume. Okay. So I'm going to go to the next page here in a second, but dilution, you do not change the drug. You are not taking, you are not adding. What you're doing is you're changing the volume by adding water or, you know, inactive ingredient. You are not changing the amount of drug. Powder volume. When constituting a powder, the powder does not vanish. That means that powder, even though you have mixed it, even though you've added a diluent and all of a sudden it's a clear liquid, it doesn't just disappear. You know, if I go back to my drawing, you know, I'm just going to go up. You know, if I go back to my drawing, just because I added that extra level of fluid, it doesn't mean that now just everything is just gone. What it means is it has been dissolved, and now that drug is you know, suspended in that, or you know, dissolved in it. Okay. So when you mix something, that powder doesn't go away. So when you calculate, you know, powder diluent is what is dissolving the drug. Okay, and I've already explained what final concentration is. I'll just do final volume. And instead of defining this in words, I can just define it in a math equation, right? Final volume is what? PV plus PV. So if I know what diluent is and I know what powder is, I just throw them together. That's it. Okay. Once again, this is related to concentration. Sometimes this can be related to the amount of drug. This can tell you the amount of drug as well. You know, like we just talked about, milligrams per mils, that has a amount of drug and it also has the amount of volume. Okay. So really the hardest part of this entire unit is to, I guess, read between the lines, right? Obviously, you know what a solution is. Obviously, you know it's something that has been dissolved that you can't separate. But if you also know that just because you dissolve something doesn't mean what you dissolved just disappeared, that's important. If you understand, if you have a percentage strength, it's already been diluted. You know, a percentage of that drug is suspended in a percentage of that medication. Or I'm sorry, a diluent. Okay, so I want you to make another attempt. So even if you made 100, go ahead and just make an attempt. And if you don't want to just do the Blackboard thing, the quizzes should be available to where you can do this. Does anyone want me to do anything else? Like any extra stuff or anything? No? Was this helpful? Yeah? Are you all having a great fall break? Okay, so
Everybody's
like I said,
speechless.
I know everyone's speechless, whatever. Go ahead and unmute yourself real quick. I just want to talk real quick about while I have y'all here about clinicals. So Jade, what is your experience so far?
I like it. It's just different, and I'm kind of struggling to learn the way they do it.
Okay, that's completely fine, right? So this is your first week, so don't get too overwhelmed. That's fine. Just stick in there for me.
Yeah, it's a little weird. So they have this new thing where, I'm sorry, my dog's crazy.
It's okay.
So they have this thing where instead of the pharmacist taking the drug after you filled it and verifying it, you take a photo of it. So
Are y'all doing remote verification stuff?
yeah.
Yeah, that's interesting.
Mhm.
Well, stick in there. Hope it gets better over time. T, have you started clinicals?
Yes, I did.
How is it
I
going?
started. It went okay. I just I went to the wrong Walgreens. So
Oh no. Okay,
they
but did
still
you figure
let
out the
me
right
do
one?
my hours there though.
And
Did
did they
they?
sign your sheet and all that stuff?
Yes, they did.
Okay.
The pharmacist.
Yeah, that's good.
Yeah.
So you know, just make sure you go to the right store next time, but that's okay. Sierra, Perla, or Pa, do you have anything? Anyone?
I haven't started yet, but
You haven't started?
kind of like, no, but kind of worried about it, but it's gonna be
Yeah.
okay.
It's okay. So, you know, obviously we'll talk a little bit more when we get back into class. But don't get too bothered by it. Things are going to be weird at first. It'll get better over time, and you'll get more acquainted to the pharmacy. And that's kind of why I don't want y'all to rotate a lot, because you'll get familiar with the pharmacy over time. Perla, do you have anything?
I haven't started yet. I start tomorrow.
Okay, cool. Where are you at? I forgot. It's okay. Just you should probably take a look at that. But just have an open mind, go there, have a good time, learn. If it's a bad experience, just work with it. Hopefully it'll get better over time. Paul, did you have anything to add? Are you good?
I have a question number 9.
Oh, number 9. What is the question?
If you add 3.3 milliliter of, the question is, what value of the final product will need?
So you said you would add diluent and then what?
If you add 3.3 milliliter of dilution
Diluent? Yeah, diluent.
of that question.
Which quiz is that?
I think the second one. I did the medication, injection medication.
Is that the one titled Dilutions Homework?
No, it's not dilution.
I don't have that pulled up. I was gonna have a question pulled up. Give me 1 second. What is the title of the homework, Paul?
Is it the injectable medication dosing homework?
Yes.
It is? Okay. So number 9. Okay. So let me get on this real quick. You can still see my screen, right?
Yes.
Okay. So the question is, and I have to do this quick, we're running out of time. So 3.3 mils of diluent to 1 gram vial now have a final volume of 4. What volume do you need to attain a 100 milligram dose? So right here, so FV, PV, DV. Do I have FV? No. Yes, I do actually, 4 mils. Do I have DV? 3.3, right? So now I can solve for PV, but I don't really need that. 100 milligram dose. So my entire vial is 1 gram. I need a 100 milligram dose.